हेलो स्टूडेंट्स, वेलकम टू फिजिक्स बुके। आज का जो वीडियो में हम डिस्कस करेंगे जनरल सॉल्यूशन ऑफ द टाइम डिपेंडेंट श्रोडिंगर इक्वेशन इन टर्म्स ऑफ लीनियर कॉम्बिनेशन ऑफ स्टेशनरी स्टेट्स। We will find out general solution of time dependent Schrodinger equation, and that solution is expressed as linear combination of stationary states. देखो हमारे पास दो टाइप का श्रोडिंगर इक्वेशन है, एक टाइम डिपेंडेंट श्रोडिंगर इक्वेशन है और एक टाइम इंडिपेंडेंट श्रोडिंगर इक्वेशन। टाइम डिपेंडेंट श्रोडिंगर इक्वेशन में हम जो फंक्शन लिखते हैं उसको ऐसे लिखते हैं साई एक्स टी, और स्टेशनरी स्टेट जो टाइम इंडिपेंडेंट श्रोडिंगर इक्वेशन होता है वहां हम लिखते हैं साई एक्स। तो टाइम डिपेंडेंट श्रोडिंगर इक्वेशन है, वी हैव आई एच कट डेल साई बाय डेल टी इज इक्वल टू माइनस एच कट स्क्वायर बाय 2m डेल स्क्वायर साई एक्स टी बाय डेल एक्स स्क्वायर प्लस भी साई एक्स टी। This is time dependent Schrodinger equation. It can also be written as I h cut del psi x t by del t is equal to Hamiltonian operator into psi x t. Hamiltonian operator क्या है? ये है माइनस एच कट स्क्वायर बाय 2m del square by del x square plus b. It is Hamiltonian operator. So this is time dependent Schrodinger equation. Here we have psi xt. Suppose this is equation. Then time independent Schrodinger equation. Time independent Schrodinger equation that is written as h psi x is equal to e psi x. You mark the difference. Here h psi xt, here h psi x. This is stationary state. This quantum state is stationary state. Here no t is there and energy eigenvalue psi x. So we will express this general solution of time dependent Schrodinger equation. मतलब we will express psi xt in terms of psi x. This is the task before us. Suppose psi xt is equal to psi x into phi t. Here I am approaching the method of separation of variables. This is position dependent function, time dependent function. Now, in time dependent Schrodinger equation, we have I h cut del psi xt by del t is equal to minus h cut square by 2m del square psi xt by del x square plus v psi xt. This is time dependent Schrodinger equation. Now put it here. What we will obtain? I h cut, यहाँ पर phi x phi t del psi x phi t by del t is equal to minus h cut square by 2m del square psi x multiplied by phi t by del x square plus v psi x into phi t. अंडरस्टूड. आगे बढ़ते हैं. देखो ये we are finding out derivative with respect to time, partial derivative, so this will become constant. I can write I h cut psi x del phi t by del t is equal to minus h cut square by 2m. Here differentiation with respect to position, so bring phi to phi t outside, it will be del square psi x by del x square plus v psi x into phi t. Now divide both sides by psi x into phi t. Dividing both sides by psi x into phi t, I will obtain I h cut by phi t del phi t by del t is equal to minus h cut square by 2m psi x phi t gets cancelled, so del square psi x by del x square plus v. Right. Now we should be observant. This side only time dependent term, and this side it is position dependent. Here only it involves only x, v, x. So a time dependent term is equal to a sum of two position dependent term only when both each of them are equal to a constant. That means this is equal to a constant, this is equal to a constant, and for both of them that constant must be same. And that constant, let me write it as E. You understood the argument? This is time dependent, this is position dependent, both are equal. So this must be equal to a constant, and to the same constant it must be equated. And that constant we suppose E. And why that is inferred, you see, I h cut del by del t. The operator, right? You can recall. So this is equated to E. I h cut by phi t del phi t by del t is equal to E. Or I can write del phi t by phi t is equal to E by I h cut dt. Now integrate both sides. If we integrate both sides, d phi t by phi t is equal to E by I h cut इंटीग्रेशन dt. और इसका इंटीग्रेशन लॉगरिथम ऑफ phi t is equal to E by integration of dt is t, so et by I h cut. Or here a constant suppose log a integration constant. This integration constant may be brought this side, so log phi t minus log a is equal to et by I h cut. It can be written as minus iet by h cut. In numerator and denominator I multiplied I, that's why this is obtained. And then using formula log m minus log n log phi t by a is equal to minus iet by h cut. And taking exponential both sides, I can find out it as phi t by a is equal to exponential minus iet by h cut, or phi t is equal to a into exponential minus iet by h cut. Taking a as 1, I obtain phi t is equal to minus iet by h cut. So this is time dependent part. Psi xt is equal to psi x into phi t. Earlier we had written this, so psi xt will be what? Psi xt is equal to psi x into exponential minus iet by h cut. This is the solution. So this is टाइम डिपेंडेंट श्रोडिंगर इक्वेशन का जो वेव फंक्शन, एंड दिस इज स्टेशनरी स्टेट, एंड दिस इज द फेज फैक्टर. This is the phase factor. Now we have already read that any arbitrary wave function can be expressed in terms of the linear combination of energy eigenfunctions. Using that principle, we can write this phi t. For each state, we have an energy value. So I can write it as phi n t is equal to exponential minus I e n t by h cut. And hence this general solution of time dependent Schrodinger equation is psi xt is equal to summation psi nx exponential minus I e n t by h cut, or I can write psi x exponential minus I e n t h cut, or it can be written as ci psi I x exponential minus I e n t by h cut. Let me write n. Cn psi n, because here n is there, so let me write n. So this is the general solution of time dependent Schrodinger equation as linear combination of stationary state. This is stationary state solution, and this is time dependent Schrodinger equation का जो solution. So general time dependent Schrodinger equation का जो solution, it is expressed in terms of stationary states. This is all about the expression of general solution of time dependent Schrodinger equation in terms of stationary states. So remember, this is the phase factor, and for time evolution we use this. Have a good day.